Let's look at operations with polynomials. Not division yet, but rather addition, subtraction, and multiplication. Addition actually is really easy, so we'll focus on a subtracting and multiplying polynomials problems as the main ones. But first we need to talk about the basic properties of exponents, because that affects a lot of what you do with polynomials now and later. And emphasize about degree and leading coefficients, and also how to recognize when it's not a polynomial. Certain ways in particular you need to see. So that's what we're going to look at here. Let's start with this. These 12 problems. Take a moment to do them yourself. Stop the video, turn it back on, and I will start going through them. Okay, now I will go through them. First, anything with a 0 automatically is 1. Doesn't matter what the base number is. That's the base number, by the way. That's what we call that. In fact, here, that and that are called the base. If they are the same base, that is then x to the 8th. The way I did that is I added those two together. When it's like this, you multiply them, so that would be 15. And the reason is because this exponent tells you to do this 3 times. So it would be x to the 5th times x to the 5th times x to the 5th. And so that would be 15 of them. By the way, back up here, the reason why this works, think about what x means, or rather the 5 and the 3 mean. The x 5 times, so that's 1, 2, 3, 4, 5. And then the x 3 times. That's a total of 8 of them. So we get 8. It's a lot easier just to do 5 plus 3. And the same thing here. I really don't want to put down 5 x's, 5 more x's, and 5 more x's and count them up. I can add 5, 5, and 5. And it's even easier to do 5 times 3. Negative exponents that we'll look at right here for these next couple. A negative exponent, that negative is not a negative sign. It's a mathematical symbol that tells you to bring it to the other part of the fraction. Every number is in a fraction. It's just there's a 1 underneath if you don't see it. So what we're going to do is we're going to bring it to the bottom. And so when we do, we change the sign. Since there was a coefficient of 1 up here, and that had an exponent of 1, that 1 stays up here. This one on the bottom is now the coefficient of the x squared. This one will do the same thing as that, except it happens to be in the denominator. So what? That doesn't matter. We bring it up and change the sign to positive. So that means that this will be equal to x squared, because now it's in the numerator. In this one, well, there's numerous ways to think about it. The mathematical official way is that there's 9 of these. I think I got 9. So these 2 cancel out, these 2 cancel out, and there's 7 left on the bottom. It's a lot easier just to bring the 2 down here and do 9 minus 7. All right, so you can either bring it down here and do x to the negative 2, and then there's a 1 still now, 1 up here, so it's 9 take away 2. In your head you can do that. So most of those are just, you just do 9 take away 2, and there's more of them down here, so it's x to the 7th. You do the same kind of thing here, but I recommend whenever you have negative exponents, just mentally it gets confusing about what you do when there's more than 1, and then you have to do something else afterwards. What you do here is just move them first. Change them to where they're positive, and then look at it. So the x to the negative 2 will come down to the bottom, and the x to the negative 9 will come up to the top. Now that's a lot easier to see what to do with. There's 2 of these on the bottom, that'll cross out 2 of those, and there's going to be 7 left. So that's x to the 7th. Okay. This one here, there is a tendency for people to recognize, aha, we're just going to do like, 3 times 5 to make 15. So here 3 times, well, there's an exponent of 1 on that. So that's going to be 3x to the 3rd power. But that's wrong, because there's a 3 on the inside. What this really is this whole thing 3 times. So that makes it 3x times 3x times 3x. So it's 3 times 3 times 3 as well. Think of it this way, that inside the parentheses we have 3 to the 1st power and x to the 1st power. So the 3 on the outside multiplies to each of these exponents. 3 to the 3rd power, 1 times 3 is 3. gives me 27. Here it's going to be x to the third power. Here I'll do the same thinking. There's an exponent of 1 on both of those, so it's now x to the fourth, y to the fourth. Here I'm going to do the same thing. 3 to the third power is going to be a 27, x to the third power. 4 to the third power, well, 4 times 4 is 16, times another 4 is 64, and that's going to be y to the first, 1 times 3 to the third power. A little thing to be aware of about these is 3 over 4 is reduced as much as it can be. When you apply the same exponent to both of them, you automatically can know that the results cannot be reduced either. So if these cannot be reduced, those cannot be reduced. If I had that as 6 and 8, 6 over 8, that could be reducible. Well, if I applied the 3 to both of those, then I would have really big numbers, and I would have to reduce it because it would be reducible. Well, if you reduce it in here first, then you don't have to worry about reducing it later. And none of these problems have reducing like that. That's another lesson we'll get to later. But you get the basics here that we're going to apply this exponent to every one of these. That really is because it's this whole thing 3 times. So we have 3x over 4y times 3x over 4y times 3x over 4y. You get the idea. 3 times 3 times 3, 4 times 4, and so on. On this one, it's the same idea, but you got that negative there. So when you have that, you can apply this to 3 negative 3 third power, x to the negative third, and you can apply it to each. Instead, I recommend that whenever you have that, use that to simply flip these. What that's telling you, every one of these is going to end up with a negative exponent, so just do it right now and just change it. So I'm going to make it 4y over 3x to the positive 3. So I'm using that mathematical symbol to tell me to make all of them go to the other part of the fraction. Now I can apply the 3 to it. So that's going to be 64y to the third over 27x to the third. On this one down here, it's more of the same, except that we have exponents on these with that exponent. And the 2 has an exponent too. You can't forget that. So 2 times 5 is 10. So on the top, we have x to the 10th. 2 to the 5th power, 2 times 2 times 2 times 2 times 2 is 32. And that's going to be y to the 20th. Don't leave as 2 to the 5th power. In other words, this is not considered simplified. That's considered simplified. So when you have a number, you actually multiply it out. The exception is if it was 18 to the 12th power, you're either going to use scientific notation or you'll be allowed to leave it as 18 to the 12th power. I don't know what huge number that is, and I'm not willing to figure it out. All right. And let's come on back down here. So now you see, it got messy here, so let's circle the answers on these. So hopefully after this you're reminded of the different ways that you would deal with exponents so that when you see them in future things coming up, you will deal with them correctly. All right. Next thing is to talk about degree and leading coefficients. All right. So for that, by the way, this part I'm going to call part 1 of this section, 4.1, and part 2. Okay. So the degree is the highest exponent of a polynomial. So let's say I see a function that's like this, 3x plus 7x to the 4th power minus 15x squared plus 9x cubed minus 1. Well, this one's leading off the thing, but that doesn't matter. In fact, one of the first things you should do is put things in order based on the exponents. But we can tell immediately what the degree is because that has an exponent of 1, here's a 4, a 2, and a 3, and no exponent at all, no variable. This is the highest one, so that's a degree of 4. You should rewrite it to put it in order by exponent. So this should be written as 7x to the 4th plus 9x cubed minus 15x squared plus 3x minus 1. 4, 3, 2, 1. And by the way, there really is a 0 here because that's x to the 0 power. It's that way. It's 4, 3, 2, 1, and 0. But x to the 0 is 1, so it doesn't affect it. So here we are. So that tells us the degree is 4. So it's a 4th degree polynomial. That's what that is, another way to say it. So I'll call it 4th degree polynomial. We usually write the word out 4th, but that's the title, that's what we call this. The other thing I want you to know, even though it's not in this section in particular, but it will come up later, so we might as well include it right now. A leading coefficient, that is not the largest coefficient like the degree is. The degree is the largest exponent. Well, the largest coefficient would be, well, 15, and really that's a negative, so it's the smallest there, but that's the largest absolute value number. But that doesn't matter. The leading coefficient is of the first term, the term that has the highest degree, or the highest exponent, it's that coefficient automatically. So in this case, it's 7. The coefficient of the first term, but only the first term when it's in correct format or correct order there. So that's what you need to be aware of about the degree and about the leading coefficient. So those are the two sort of like vocabulary things I want you to be aware of. Okay. The next thing, let's talk about the things that are not polynomials. Well, first, a polynomial is made up of terms. It can even be just a monomial, 1, but poly means many. So 1 is the smallest amount of many, I guess is one way to think about it. We usually use monomial for a single one and polynomial for all the others. A binomial, well, let's write those out. Monomial, a single term like, say, 3x. Because if it's combined by multiplication or division, it's a term. If it was adding or subtracting, it would be two different things. In fact, that's a D, I meant to put a D. Binomial, bi means 2 of something. So if I did 3x minus 4, that's a binomial because there are 2 terms. And then a polynomial would be more than that. Well, this could be considered a polynomial. Many terms, just that would only be 2. All right, so that being said, let's look at the basic idea of a polynomial. Function of x is equal to, let's call it x to the 5th minus 3x to the 4th plus 9x to the 3rd plus 4. I don't want to write more here. Notice the exponents are integers. Notice there's one variable. Now, this could be considered y, but y is not really a variable here because f of x, y are the result of putting a number in for x. When you put a number in for x, you get a result out. Therefore, there's only one real, actual, practical variable that you're going to use, and that's the x. So there's only one variable. If I had y over here or z or anything else, then it wouldn't count as a polynomial. It would be something we use in different ways, such as conics, where we have an x and a y both, and we make a circle or an ellipse or a hyperbola, but it's not a polynomial. It has 2 variables in it. All right, so those are a couple of the main things. Let's see. Notice that the variable is like in the top of the fraction in each of these cases. So if I did have that as negative 3 over 2, well, the x to the 4th would have to be in the top part. Now, let's look at some things that are not polynomials. So, not polynomials. All of this I'm going to say is like A, and then this will be like part B. So, here, let's look at some like samples. The function of x is equal to 35 over x to the third power. That is not a polynomial because the variable cannot be in the denominator. Then let's look at this one, 35x to the negative 3. Well, these are actually the same. Remember the stuff about the beginning of this lesson where if it's a negative exponent, it's telling you to bring it to the bottom of the fraction and make it a positive exponent. So this becomes that. So that means when you see a negative exponent, you know that really you have something that's in the denominator. So that means that the exponent, I will say, cannot be negative. I was about to say exponents must be positive, but then zero is not considered positive or negative. Next to the 0 is acceptable. That's how you get that ending term like before here, because that's next to the 0 that's with it. All right, over here, let's do another one. The function of x. Well, the function of x equals x to 3 over 2. That's not a polynomial. This has to be an integer, not a fraction. Okay, so exponent cannot be fractional. Now we're talking normal fractional. Yes, the number 5 over 1 is a fraction, but it's considered an integer when you have a 1 underneath it. So you don't have to get that technical. In fact, it's not considered right. The 5 over 1 is an integer because it's an unseen one. It's when it's over anything else that it's a fraction and cannot be a polynomial. Now, look at this. The square root of x, and let's say we put even, there's a good exponent, 3. But the square root means that you can't count it. So no square roots. No square roots of the variable. If one of the coefficients, like say this was, instead of 9, say we had 8 here, and we had square root of 8, or minus the square root of 3. That would be okay for the number, because it's just a decimal number, and the coefficients can be any weird numbers you want it to be. It's just the x's, the variables, we have to be picky about, and their exponents. Now, these two are the same. The denominator for a fractional exponent is actually the root of something. So that means this 2 brought in front as a square root means the same thing as this. These two are actually equal. But if you see it in this form, you know it's not a polynomial. If you see it in this form, you know it's not a polynomial. All right. And the last one we'll look at here is, let's say we have 5x squared y plus 7x minus 3y. Two variables. No. Cannot have two variables. Y over here would be okay. So y equals x to the 5th minus 3x to the 4th. That's okay. Anything over here equals, when it multiplied together like this, x squared y, no. That's not acceptable, right? And even this one, we would have to adjust and change it. That's what we're looking at mainly. I won't be giving you both of those. Okay, so be aware of these things that are not polynomials and these types of reasons, so that if you have to identify some and say they are polynomials or are not polynomials, make sure you can say why it's not a polynomial. And these are reasons why it's not polynomials. Okay? Can't be in the denominator, can't have a negative exponent, can't have a fractional exponent, can't have any roots, square roots or others, so I shouldn't say square roots. Say that was a 5, that would be the 5th root of x to the 3rd, and that wouldn't be equal, so no roots. And you cannot have two variables, especially, and it's really clear when they're multiplied together like that. Okay, now let's do a couple of the types of problems that you need to be comfortable with. And so we're going to do a subtracting problem. subtract. And I'm going to give you this problem, 8x squared minus 7x plus 5, take away 5x squared plus 3x minus 2. Go ahead and do that yourself first right now. In about 3 seconds on the video here, I will do it. So stop it and then start it again as soon as you're done. All right, now I'm going to start going through it. Well, this here, the parentheses aren't necessary because it's this and then subtracting these things. So I'll just write it out. But this is where you have to deal with something the correct way. That subtract means we're going to subtract 5x squared, so it's going to be 8x squared, take away that. Then it's going to be negative 7x, take away 3x. And then we're going to take away a negative 2. So what I recommend to do whenever you're in this situation is to multiply that negative into each one of these things, which means you'll change each of the signs. This becomes negative 5x squared, and a negative times that is negative 3x, and a negative times that is a positive 2. Now you can combine like terms. So now we have 8x squared, and take away 5x squared gives us 3x squared. Negative 7x, take away 3x is negative 10x, and 5 plus 2 is 7. Now, if you didn't do that negative right, some people might have done negative 7x and plus 3x because they might have applied this to only the 5 and not applied it to the others. So if this were a test problem and someone answered 3x squared minus 4x, immediately I would know that they did not change that 3 to a negative like they were supposed to. And 5 take away 2 would be 3, so if they had a plus 3, I would know that they were wrong too, because they should have made that a plus 2 and then added it to the 5 to make 7. So this and this would have been incorrect. And those are very common mistakes. I often see people having done the first one correctly, but then the other two wrong because they didn't change the signs. Watch out for that when you're subtracting and make sure that you're very careful to avoid that error. Now, the fifth part is multiplying. So when we're multiplying them, let's take a look at this example. 2x squared minus 5x plus 1 times 3x squared minus 2. The textbook shows to take this times each one of those, so it would be 2x squared times 3x squared, and 2x squared times negative 2. Then negative 5x times that, negative 5x times that, and 1 times that, and 1 times that. Perfectly fine. Personally, I prefer using the binomial, and this is multiplying, so it doesn't have to stay in the back. Perfectly fine to be in the back, but you can switch it. Just like you can have 2 times 3 is equal to 6, and 3 times 2 is equal to 6. If you're multiplying, you can switch them around. So I'm going to take that and I'm going to put it in front. 3x squared minus 2, 2x squared minus 5x plus 1. So I'm going to do first the 3x squared times each one of these three things. 3 times 2 is 6. X squared times x squared is x to the 4th. Then I'm going to do it to this one, negative 15 x to the 3rd power, those exponents. And then 3x squared times 1 is just 3x squared. Then I'm going to do it here. Now when I do negative 2 times 2x squared, that's 4x squared, and I'm going to actually put it right underneath this one, so in a moment when I put all the terms together, I'll just add them together. Negative 2 times negative 5x is negative 10x. Oh, wait a minute, negative and negative is a positive 10x. And negative 2 plus 1 times positive 1 is negative 2. Now, let's double check all those negatives. Negative times a negative 2 times a positive 2 is a negative 4. Aha, good thing that I checked it. So I'm going to make that a big negative there. And remind myself that that's a negative. All right, so that's negative 4x. Very important to see that. Then when I do this, that's a positive 10. 2 negatives make a positive. And a negative by the positive is negative. So it's a good thing I went back and checked that because I accidentally made that mistake. It wasn't even on purpose this time. Well, there was only one. Oh, let me check the other one because there was a negative here. Did Did I do this one right where I got negative 15? Yes, it looks good. All right. So my answer is 6x to the fourth minus 15x cubed. These two are combined to negative x squared plus 10x minus 2. And that's the result of multiplying these two together, where we end up with a fourth degree polynomial because the two largest exponents end up multiplying to each other. And just be careful when there's any negatives in there. Like I almost missed this one. Okay? Negative there, or positive there, and negative there. All right. So what you have seen in this lesson, let's go back to the beginning of it. You have seen a reminder about the properties of exponents and how to use them. Okay. Then you have seen about monomials, binomials, and what polynomials should look like, and what things are not polynomials. And you have seen about, did I have a second one? Oh, and also, just to mention that you have seen about a degree, the degree and the leading coefficient. Remember what those mean. You've seen how to subtract and multiply polynomials, being very careful with the negatives, making sure you change signs when it's appropriate, and the same thing here when you're multiplying. I didn't do the adding one because the adding one is just too easy. If that was plus, then you wouldn't have to worry about changing signs at all, so it would be the same basic thing. And the only operation, therefore, not included here is the division. Dividing polynomials, there are 3 ways to be considering that, and that's in a different lesson that you can enjoy separately. But now you have enough to be able to do these things correctly. Just pay attention to your negatives and be very careful with them. Thank you for listening.